All right, guys, I've got a fun coding challenge for you today, and it is a problem called FizzBuzz. Now, this is probably one of the most asked questions at interviews for programmers because it tests the way that you think and it allows the interviewer to see how you use your logic to solve a problem. And the problem we're going to tackle is a children's game called FizzBuzz. Last time I checked, the programmatic solution was actually up on Wikipedia, so I recommend reading the Wikipedia article only after you've solved this programming challenge. The rules of FizzBuzz are really simple. Basically, you have a bunch of kids who sit around in a circle, and going clockwise, the first kid says 1, the second kid says 2, but then when a kid encounters a number that's fully divisible by 3, then instead of saying that number, he's going to say fizz. And when the number is divisible by 5, instead of saying the number, they should say buzz. And if the number is divisible by both 3 and 5, for example 15, then they should say FizzBuzz. So your program is going to replicate this for all the numbers up to and including 100. To start off, it'll probably look something like this. It's going to print 1, and then on the next line it'll print 2, and then fizz, because 3 is divisible by 3, and then 4, and then 5 is divisible by 5, so it's buzz, and then 6 is fizz because it's divisible by 3, and so on and so forth. This is what your program has to do. Take a look at the instructions, make sure that you understand what it is that your program has to do, and then pause the video and try to give this a go. All right, so the first thing we have to do is to create a range, right? So let's say that for number in range, and our range is between 1 and 100. So we have to include 101 in here. And what we want to do is we want to check whether if the number is divisible by 3, divisible by 5, or if it's divisible by both 3 and 5. Now, we could write our code by doing this in order, right? We could say if number modulo 3 is equal to 0, then it's divisible by 3. So you might think that you could write the code like this, but there's a crucial problem in the logic here. Namely that we know that the if, elif, else statements will stop once it's found one statement that's true. For example, if we take the number to be 15, 15 divided by 3 is equal to 0, so it's going to carry out whatever instruction is inside this if statement, and then it's going to be done with it. It's going to skip this one, and crucially, it's going to skip this one, which is what we really need. Instead of structuring our code like this, what you might have done, and what you should have done, is in fact have this at the top. So first check if it's divisible by 3 and by 5, and then if that's not true, then check to see if it's divisible by 5 and then divisible by 3. Or the other option works as well. You could do it like this. Because these two have no overlap in terms of the results, then it doesn't really matter. So now we can finally write our code, because we can say, well, if the number that we're currently encountering is divisible by both 3 and 5, then we have to print FizzBuzz. If it's only divisible by 3, then we're going to print fizz. And if it's only divisible by 5, then we're going to print buzz. Now, that still leaves the remaining numbers, right? Because the remaining numbers, which don't fit any of the criteria, should just be printed out as the number. We can catch that quite easily with an else statement that catches basically every other number, in which case we're just going to print the number. So now if I go ahead and run this code, then you can see that all the way from 1 to 100, it's been able to work out which ones are fizz, which ones are buzz, and which ones are FizzBuzz. How did you get on with it? If you got stuck, or if you don't understand why this logic matters, then I want you to try both versions that I showed you and see it step by step using the Thonny program, just as we did before. That way you can visualize what's actually happening in terms of the logic and how it's flowing from one step to the next to the next. Now, once you've done that, then go back to your exercise and try to complete it. it's really, really important that you don't just say, oh yeah, I understand now. It's a really good idea to make sure that your code actually works at the end of the day and to write the code yourself. Today we've learned all about loops and we're going to apply it in our final project. So that's what's waiting up for you in the next lesson. So head over there once you're ready.